Alright, in this video what I'm going to do is I'm going to go over topic number 2 for the 2013 final exams, which is number and algebra. There's a couple different parts to this. There's 5 parts actually, so these videos are going to be kind of long, but I'm just going to try and piece them together to make sure everyone's prepared here. Let's look at the first thing, arithmetic and geometric sequences in series. These can be a little tricky sometimes. The best way to do these problems is to decide whether the sequence is arithmetic or geometric. The question often tells you, actually. And then use the formulas in your formula booklet to solve these problems. Okay, so what I'm going to do is I'm going to go through 5 examples right now. A couple easy ones, and then I'm going to do the trickier ones of these. Okay, in the first example it says, here are the first 5 terms of an arithmetic sequence. Okay, well that's nice because they give us the first term. Write down the 6th number in the sequence. Okay, well, first of all, we need to find out what the common difference is. And if you look at this, you just need to do 6 minus 1 or 11 minus 6, and you get 5. So the common difference is 5. So the 6th number here, 1, 2, 3, 4, 5, 6, you're just going to have to add 21 plus 5. So the 6th number would be 26. Okay, pretty simple to start off. B, let's see here. Write down the 50th term. Okay, well now here's where we're going to use the formula. So the nth term is the first term plus n minus 1 times the common difference. Okay, so what we have to do is sub in what we know from here. So like we got right here, it's the 50th term. Well, we know the first term. The first term is 1. Okay, and then we can just do, n is 50, so 50 minus 1, and then we know the common difference is 5. So we'll just put that in there. Once you set that up, then you just go straight to your calculator right here. I'm in applications, which is interesting. Get out of here, second quit. Okay, so we'll just do 1 plus 50 minus 1, well, obviously that's 49, but I'll just put the whole thing in there. It doesn't matter. And then 5 is 246. So our answer here is 246. So that's the 50th term. The 50th term is 246. Okay, and then let's do calculate the sum of the first 50 terms. Okay, again, this is where you use a formula. So the sum is n over 2 times the first term plus n minus 1 times d. Okay, so again, just sub in all the numbers. That's, these problems can be pretty straightforward when you just sub things in. So we're going to do, 50 over 2 equals 2 times 1 plus 50 minus 1 times d, which is 5. And you'll notice that it's close to, this is just going to be one more than what it was before because we're doing 2 times 1, but whatever, we'll do it on the calculator. So 50, the sum of the first 50 terms, so 50 divided by 2 is 25, okay, times 2 plus, 49 times 5. Okay, so let's just break out the calculator again, and we'll do 25 times 2 plus 49 times 5. And what do we get there? We get 6,175. So the sum of the first, it gets pretty big pretty fast. 6 is 6,175. Okay? So that's a pretty straightforward one, but that's often like a paper 1 problem that you would see there. Let's move on to a geometric sequence one. Okay, in this problem it says here's a geometric sequence, and it goes 54, again, they're giving us the first term again, which is nice. 54, 18, 6, and 2. Okay, no problem. Okay, so the way we look at this, find the common ratio. Okay, well, again, you just have to divide here instead of subtract. So for part A, it's going to be 18 divided by 54. And this is a fraction, okay? Like it's 1/3. Now, what I would do if I were you, this is a repeating decimal, 0.3. So if you did 18 divided by 54 like this, I wouldn't round it right now. Your answers are going to be off if you round it. So and if you don't know that that's 1/3, all you have to do is press math and then fraction, and it will give you it's 1/3. So I would keep it as a fraction. It makes doing these problems much easier. So like if they want us to find the 7th term, okay, so now we're going to use the formula, the nth term equals the first term times the common ratio, which is what we just found, and to the n minus 1 power. So again, for the seventh term, we'll just do 54 times 1/3 to the n minus 1, so it's going to be 7 minus 1 to the 6th power. Okay, so once you set that up, again, just bust out the calculator. Let's clear this stuff out, and we'll do 54 times 1 divided by 3. Make sure you put brackets. Raise it to the 6th power. Boom. Okay, and we get a fraction or a decimal there. So you'd want to put 0.0741 if you did the 3 significant figures. But I'm just going to leave it as a fraction. So I'm going to go to math, and I'm going to go to fraction, and it's going to be 2/27. So that's a much easier, simpler answer to give. So I'm just going to go with 2/27 there. And that is the 7th term again. Okay, and then find the sum of the first 10 terms. Okay, now this is where you have to be careful with your calculator because a lot of kids make mistakes on this. So the sum of the first n terms is the first term times the common ratio to the nth power minus 1 over the common ratio minus 1. Okay, so in this case, it's going to be the sum of the first 10 terms, which would be 50. Or I'm sorry, this is the first term. So 54. I don't know if I said that or not. 1/3 to the 10th power minus 1 over 1/3 minus 1. Okay, now you can enter all this in at the same time. It can get a little dicey, but let me show you how I'm going to do this. I am going to go, let's see, I'm going to go 54, and I'm going to put big brackets here. So second big brackets. And then I'm going to do small brackets for the fraction. 1 divided by 3. Oops. 1 divided by 3 raised to the 10th power. And then you have to arrow over. Minus 1. And then I'm going to put big brackets again. Okay, and I get my answer here, which is whatever. Okay, that's basically negative 54. And then I'm going to divide that, and I'll just put brackets again. 1 divided by 3 minus 1. And order of operations will take care of that. So as long as you put brackets, you're fine. And boom. So the answer there is going to be 81 if you rounded it. Yeah, 81 to 3 significant figures. Okay, so and a lot of that has to do with actual rounding. The number is 81. So the sum of the first 10 terms is 81. Okay, so not too bad. Those are 2 pretty simple ones. Let's move on to some that are a little trickier. Okay, the tricky problems for sequences in series normally have you create systems of equations to solve for the difference or the common ratio and the first term, or have you solve for k in a sequence. Okay, so let's do some examples of those. So if you look like right here, it says the first 3 terms of an arithmetic sequence are k plus 4, 5k plus 2, and 10k minus 2. Show that k equals 2. Okay, this is one of those show that problems where you got to show, all your work here to make, they give you the answer k equals 2, which is fine. Okay, so in this case, we know this minus this will equal this minus this, because that's the definition of an arithmetic sequence. So I'm going to do 5k plus 2 minus k plus 4 equals 10k minus 2 minus 5k plus 2. Okay, and then in this case you just have to distribute. So you get 5k plus 2 minus k minus 4. Some kids will put plus 4 there. 10k minus 2 minus 5k minus 2. Okay, and so combine like terms here. You get 4k minus 2 equals 5k minus 4. I'll just move this over here and that over there. So I'm going to get 5k minus 4k equals negative 2 plus 4, and then we get k equals 2. Okay, so you're going to have to show those steps for ones like that. Now, if you don't really get that part, you can actually still do the rest of the problem because they tell you what k is. So when they say for part B that they want you to find the values of the first three terms, well, we'll just plug it in. So, we have 2 plus 4, which is 6, and then we have, 5 times 2 plus 2, which is 12, and then we have, 10 times 2 minus 2, which is 18. So our first three terms are 6, 12, and 18. Okay? And then what do they say for C? Write down the value of the common difference. Well, obviously it's going to be 6 because it's 12 minus 6 equals 6. Nice. And then calculate the 25th term of the sequence. Okay, fine. No problem. So again, we'll do, the nth term of the is the first term plus n minus 1 times d. And so the 25th term equals, 6 plus 25 minus 1 times common difference, which is 6. Okay? And we'll just, plug that in. So a lot of this is calculator work. Once you plug everything in here. And so we get 6 plus 25 minus 1 times 6. And we can just put 6 there. And we get 150. Okay, so that's going to be our 25th term, and then find the sum. Okay, so again, this is the same type of problem we did before. I'm not going to write down the formula again. I'm just going to do it. Sum of 25 terms is 25 over 2 times 2 times 6, which is the first term, plus, 25 minus 1 is going to be 24 times 6. Okay, so, I mean, once you know these formulas, you can start to put them in a little. So it's going to be 12 and a half times 12 plus 24 times 6 is what? 120. 24 is 4. Carry the 2 is 144. Okay. So it's going to be 12 times 156, basically. Okay, so let's do that. 12 times 156. Wait, did I do that wrong? I may have done that wrong. It's 12.5. Oh, 12.5. I knew I did something wrong. Times 156. So you got to be careful of that. I was just being stupid there. Okay, so equals 1950. All right, so I'm just going to put it over here. Okay, so there you go. That's a K problem. Normally that's with an arithmetic sequence. Okay. Ooh, it's 150. Woo. Difference is 6. Okay, and that's pretty good. Okay, so now let's go on to some systems of equations problems. Okay, for this one it says the sixth term of arithmetic sequence is 20, 11th term is 50, find the common difference and the first term. Okay, no problem. So this is a very, very typical problem on an IB test. And what you just have to do is you have the sixth term is 20 and you have the 11th term equals 50. Okay, now we can just sub this into the equation. Okay, so remember our equation, which is the nth term equals the first term plus n minus 1 times d. Okay, so what we're going to do is just sub this in. So I'm going to do, we already know the answer. We know the answer to this. So we're going to just do 50 equals, we don't know the first term. We know n minus 1. Well, it's 11 minus 1, so it's going to be 10d. And then we'll sub that one in. So we know the answer, 20. We don't know the first term. We know it's the sixth term, so 6 minus 1 is 5d. Okay? Now, the beauty of this is a simultaneous equations or a system of equations, so you just have to subtract it. Okay, so 50 minus 20 is 30. Now, when you subtract this one minus this one, first term minus first term, it goes away, so that's beautiful. Cancels out one of the variables, so we get 5d here. So again, we'll just divide by 5. We get d equals 6. Okay, so we're halfway done. We found the common difference. Now we just have to find the first term, and so you just take either one of these and plug it in. So I'm just going to do 20 equals the first term plus 5 times 6. Okay, so that's 30. So we're just going to move the 30 over there. 20 minus 30 is negative 10 is the first term. Okay, so the trick part to that is to set up the simultaneous equations. Okay, now once you do that, they always ask you to, you know, find the sum or whatever, the next or the 50th term, whatever. And you know, even if you mess this up, still go ahead and do the second part because you can get follow-through marks for that. Okay, so calculate the sum of the first 100 terms. So S of 100 equals 100 over 2 times, what was the first term? Negative 10 times 2, sorry, I have that backwards. It should be 2 times negative 10, not that it matters, times, you know, 99, 100 minus 1, times the difference, which is 6. Okay, so, you know, let's just write this out. So it would be negative 20 plus, that's 6, sorry, 6, 99 times 6. Okay, so again, I'm just going to get out my calculator. You know, don't waste your time. I'm wasting a lot of time here doing this by a lot of mental math, and it's easy to make mistakes doing that, so I wouldn't recommend it personally, but whatever. Okay, boom, boom, 28,700. Okay, so the sum of the first 100 terms is 28,700. All right, boom, we're done with that one. Okay, so let's move on to a geometric one, and then we are done with sequences and series because this is getting old. All right, hold on. Okay, and then finally the last one here. A geometric sequence has a second term of 30 and a fourth term of 120. Find the first term of the common ratio. Okay, so again, we're going to set up, we have a second term of 30, and we have a fourth term of 120, and we're going to set up simultaneous equations here. You always want to do the highest term first on these. Okay, so it's going to be the first term times r. Well, we don't know what r is, to the n minus 1 power. Well, this is the fourth term, so n minus 1 is going to be 3. And then on this one, we have 30 equals the first term to the n minus 1 power, so it's going to be r1 right there. Okay. Now, in this case, we just need to divide them. Okay, so we're going to divide, and we get 4 equals, this goes away. The first term divided by the first term is 1, so we don't need to write it. And then it's going to be r squared. So, you know, basically we just need to take the square root of 4 equals r, so r equals 2, which is nice. It's a nice, easy number. You know, if you ever see something like this, just on a side note here, I see a lot of kids mess things up like this. You know, 32 equals like r to the fifth or something, and a lot of kids don't know that if you want to take the fifth root of something, like the square root right here, what we did is really 4 to the 1/2 power. That's the square root. So like if you ever want to take the fifth root, just do 32 to like the 1/5, or you know, sometimes it'll be like 27 to the 1/3. 32 to the 1/5, by the way, is 2. 27 to the 1/3 is 3. Just so you know, those are some common ones they use. So that's just all calculator work right there. Now, what are the? We need to find the first term now. So it'll be 120. I'm just going to sub it into the first one, equals the first term times 2 to the 3rd power. So we get 120 equals 8 times the first term. I just kind of move those back. Move those over. I'm going to divide. So it's going to be 120 divided by 8 equals the first term, which is 15. 120 divided by 8 is 15. Okay. So we're all good to go there, and now we can just, you know, we can find some answers here. So the sixth term, is going to be the first term, which is 15, times the common ratio, to the 6 minus 1 power, which is 5. Okay, and so you start to get, you can see I'm starting to do these a little faster. I mean, obviously I know how to do them, but you know, as you practice a little more, they get pretty straightforward. You're just subbing stuff in. Okay, boom, is 480. Okay, so the answer here is 480. And then we're going to find a sum, right? Sum of the first 8 terms. Again, be careful with this. It's going to be 15 times 2 to the 8th power minus 1 over 2 minus, oh, this is beautiful. On the bottom it's 1, so we don't even really have to worry about that. So let's just do that again. And we'll do, you know, 15 times 2 to the 8th power minus 1, boom, is 3,825. Okay, so 3,825. All right, so that's a wrap on sequences and series. It's a good topic, and there's actually usually problems on paper 1 and paper 2 about it. So if you got this down, you should be good to go. All right. Okay, for section 2 here, we're going to do number sets. Number sets are pretty straightforward, but a lot of kids miss these problems, and you really shouldn't be missing these. You just have to understand the relationship between all the numbers. Okay, so for number sets, you must be able to identify and understand the relationship between real numbers. So every number we use in studies is real. Rational numbers, Q. Well, rational numbers are just any number that you can make into a fraction. Integers, those are positive and negative whole numbers, and natural numbers are the counting numbers starting at 0, so like 0, 1, 2, 3, 4, 5. Below is a Venn diagram that illustrates the relationship between these numbers. Okay, so like you'll see here, so if you start, right in here at natural numbers, as part of this Venn diagram, the thing to understand is like natural numbers, 0, 1, 2, 3, 4, all whole numbers greater than 0. 0, 1, 2, 3, 4. Integers, well, it's 0, 1, 2, 3, 4, but then all the negative numbers, like negative 1, negative 2, negative 3. So natural numbers are also integers. And then integers are also rational numbers. Rational numbers are any number that can be expressed in a fraction in the form of a over b, where a and b are integers and b is not equal to 0. Okay, so if you look at this right here, this is kind of a handy little cheat sheet. Real numbers, it's all numbers that used in studies are real. Okay, rational numbers are anything that can be expressed as fraction. Integers, positive, negative whole numbers. Natural numbers is greater than or equal to 0. And then irrational numbers. Now irrational numbers, they're always going to use like pi. These are numbers that can't be expressed as a fraction. Like pi is a non-terminating decimal that doesn't repeat, and then like any square root that's not a whole number. So like square root of 5, square root of 13, square root of 11, anything like that. Okay, so if you just take a look at this, study it a little, make sure, and there's a couple problems coming up that show you how to do this. You don't want to. These are normally fairly simple problems. They'll be like one of the first paper 1, like first 2 or 3 problems. You definitely want to know how to do these. Okay, so here's a typical problem. It says consider the numbers 5 pi over 2, negative 3, 5/4, 2/3, and the number sets n, z, q, and r. Complete the following table by placing a tick in the appropriate box if the number is an element of the set. Okay, so this is pretty straightforward. Let's look at the number 5. Okay, I always like to start in the lowest one. Is it a natural number? Well, yeah, it is. It's a counting number, right? So if it's that, it has to be all the rest because these are in order. Okay, so it has to be an integer. It has to be a rational number. It has to be real. Okay, now let's look at pi over 2. Well, is it a natural number? No. Is it an integer? No. Now, this was where you may be getting confused. Is it a fraction? Well, actually, this isn't the straight definition because pi is not a whole number. Pi is irrational, so this is going to be right here. Now, negative 3, is it a natural number? No. Is it an integer? Yeah, it is. Okay, well, that means it also has to be these two right here. Okay, 5 over 4, is it natural? No. Is it an integer? No. Well, it's a rational number, and it's a real number. And same thing with 2.3. That's not natural. It's not an integer. It's going to be a rational and a real number. Those are pretty straightforward problem, but my guess is just kind of like Venn diagrams where you work out. Start in the middle in natural numbers and work out, and it shouldn't be that tough for you. Let's move on and try another one. Okay, for this second one, it says consider the universal set of all positive integers z less than 13. Okay, so anytime I see something like that, and it says A is the prime numbers, B is the square numbers. Okay, anytime I see something like this, I want to make my universal set. Okay, and my brackets suck, I'm sorry, but you're just going to have to live with it. My kids give me so much crap about that all the time. 8, 9, 10, 11, 12. 11, 12. Okay, so it's basically 1 to 12. There's 12 numbers here. Okay, well, that one wasn't bad. Okay, so let's list all the prime numbers. Okay, so A equals, now prime numbers, guys, is numbers that have two factors, one in itself, okay, and just so you know, 1 is not prime. 1 is not prime. Okay, that's a huge mistake that kids make. Okay, so the first prime number is 2. That's the only even prime number. Then it goes 3. 4 is no good because it's even. 5, 7, and 11. Okay, they always ask you for some prime numbers on these. Now, all square numbers. Now, square numbers are like 1 squared is 1, 2 squared is 4. Whoa, sorry, 2 squared. 3 squared is 9. 4 squared is, I think you get the point here, 16. Okay, now 1, 4, and 9 are the only ones that are part of that set. So we'll just go 1, 4, and 9. Okay, now C, the multiples of 3. Okay, now multiples is when you skip count. So if we're going to skip count with 3s, you go 3, 6, 9, 12. Okay, so boom. Okay, so 3, 6, 9, 12. And then D, you know, with a set of factors. Now, factors are numbers that multiply. So the way I always do this, and I tell my kids to do this, is if it's 36, I just start at 1. 1 times 36. And then, you know, it'd be 2 times 18. 3 times 12. You know, 4 times 9. And 6 times 6. Okay, so we want to know the ones that are in between 1 and 12 there. So we, you know, it's 1, 2, 3, 4, 6. Well, we only have to do 6 once. 9 and 12. Okay, so those are gonna. So 1, 2, 3, 4, 6, 9, and 12. Okay, and so there you go. That's sets. Okay, so. Now, this is a really short problem I put up here. Normally what this will involve is a Venn diagram, which we'll get into in topic 3, and maybe even some probability. But it's important that you make these sets. Now remember also, though, even if you don't make the sets properly to begin with, still do the rest of the problem because you can get follow through on that. So, you know, even if you mess up one of them, like if you put 1 as a prime number, I swear, no, I'm just kidding. But it's kind of frustrating. 1 is not prime. 1 is not prime. Okay, so anyway, there you go. Okay, for part 3 here, we're going to do approximation, significant figures, and percentage error. Okay, remember that all your answers on your exams must be rounded to 3 significant figures unless it states otherwise. Otherwise, you get a 1-mark accuracy penalty per paper, and you know there's a financial penalty, an accuracy penalty, and a unit penalty. If you bust out 3 of those on each paper, that's really going to affect your grade. So you know we don't want to do that. So this is the formula that's given in your formula booklet for percentage error. You know it's pretty straightforward. And then, you know, and then another thing you also need to know here is scientific notation, or it's also called standard form. It's like some of the British textbooks. So A times 10 to the K, where A is, you know, greater than or equal to 1 but less than 10, and K is an element of integers. Okay, so just a couple things. This is pretty straightforward. Again, these are like usually paper 1 problems that are pretty straightforward. So let's go ahead and do one. Okay, so in this one it says let x equal 30 y squared over the square root of y plus 1. Okay, find the exact value when y is 1.5. So it's going to be, you know, 30 times 1.25 squared divided by square root of 1.25 plus 1. And again, we can do this, you know, straight on a calculator. Turn it on, we go 30 times 1.25 squared divided by the square root. Oops. We don't want that. Okay, so second square root. What's my problem here? Okay, second square root. There we go. It'd be 2.25, right? And so we just do enter on that. 31.25. Okay, so we're good on that. So 31.25. Okay, so it says give the exact answer, so we're not going to round that. So look at part B. Write down the value of x to 3 significant figures. Okay, well, 3 significant figures, it's going to be 1, 2, 3, so we just need to round. So it'd be 31.3. It's because this is 5 or greater, so you're going to round up. And then we want to put this in scientific notation. Write down your answer to part B in the form a times 10 to the k, where, okay, so, well, that's scientific notation. Okay, well, what you need to do there is, you know, you just move this over once, and you get 3.13 times 10 to the first power. Now, if you don't know how to do scientific notation, it's too late to learn it. So what I would do is just do it on the calculator, and the way you can do it is just go normal, go to scientific, type, and then we'll type in the number. So we'll go to 31.3 and just press enter, and it will give you the answer here, 3.13. In E, you don't write E. That means the exponent is 1. So you would write it like this, 3.13 times 10 to the first power. Now the only problem with this is you got to make sure you put your mode back to normal when you move on to other problems, or all your answers are going to be in scientific notation, and you don't necessarily want that. Not that it would be the worst thing in the world, but okay, so you're good to go with that, and let's go on and try another one. Okay, it says the mass of a container is 2,690 kilograms. Write down in scientific notation. Okay, so, well, again, I'm just going to make a decimal here, you know, 2.69, and then it's going to be times 10, because I moved 1, 2, 3 spaces, so it's going to be times 10 to the third power. Nelson estimates that the mass of a container is 2.7 times 10 to the third power. Okay, so, well, that's basically 2,700. That's what he estimates. Write down the mass in full. Okay, well, you move 3 spaces to the right. I just did it. It's going to be 2,700. And don't forget kilograms, because you get a unit penalty there. Now, find the percentage error here. Okay, so the percentage error is, the formula is the approximate minus the exact over the exact times 100, and it's always positive. Okay, so in this case we're going to do the approximate, which was 2,700 minus 2,690 over 2,690, and you know, well, I'm not going to just go through all this. I'll save you the time, and then you times it by 100. Well, times it by 100. And what we're going to get here is, it's really small, 0.372%. Okay, so that, you know, with percent error, just make sure you use the formula. You know, the approximate is when the rounded, when they estimate or something like that. The exact is obviously the exact weight, and those are pretty straightforward. Okay, so let's move on to the next topic. Okay, for the fourth part here, we're going to do systems of linear equations, okay, or also called simultaneous equations. Problems where the solutions needs to be found for 2 equations, linear systems or simultaneous equations, are best solved using the polysimultaneous 2 application on your calculator. You need to make sure you have this. It's the only one the IB allows. It's really good. You use simultaneous equation solver in the app. Okay, and I'll show you how to do that in just a second. Okay, so the cost C in Australian dollars of renting a bungalow for n weeks is given by the linear relationship C equals n times R plus S, where S is a security deposit, R is the rent. Fine, great. Anna rented the bungalow for 12 weeks and paid $29.25. Okay, and Raquel, I guess that's Raquel, rented the same bungalow for 20 weeks and paid a total of $45.25. Okay, so what you need to do here is you need to just make 2 equations. So the cost is, the first one would be $29.25 equals, she went for 12 weeks, so 12 times R plus S. And then the other one is $45.25 equals 20 R plus S. Now, this is actually a really easy one because you can subtract them and they go away. So let me do it algebraically. So if you subtracted this, let's see, what would you get? 2925 minus 4525 is negative 1600. Okay, that's fine. Negative 1600 equals negative 8r. So we divide by that. So r is going to equal 200. Okay, so if r is 200, then we can sub it in here, and it would be 2925 equals 12 times 200 plus s. So that's going to be 2400 plus s equals 2925. Okay, so subtract, it's going to be 525 for the security deposit. Okay, so what we found here is that it's 200 AUD and 525 AUD. Okay, now let me show you how to do this on a calculator. Now let's see. The best way to do this, because they're not always going to be that easy to cancel out, so you always want to go straight to the apps and go to the second one. You'll have two apps, finance and that one, and simultaneous equation solver. Now we have two equations, we have two unknowns. I want my answer, I don't want in fractions, I want in decimals, so I'm going to go down and change that. And then you just go to next, and we'll enter it in. So it would be, you enter the the right side here. I wrote it differently, but the total is always going to be on the right here. So it's going to be 12 plus, enter 1, enter 29, 25, enter, and then the other one's going to be 20, enter 1, and then what is it, 45, 25, enter, and then boom, just solve it, and it gives us 205.25, which was our answers. But if this was like 4s and this was 3s, it gets a little more complicated. So I would just straight go into this. It's much easier, and you are good to go. Okay, let's move on and try another one with that. Okay, here's one that's a little trickier. It says Keisha had 10,000 US dollars to invest. She invested M US dollars in Midland Bank, which gave her 8% annual interest. She invested F US dollars in First National Bank, which gave her 6% annual interest. She received a total of 640 US dollars in interest at the end of the year. Okay, so write two equations to represent this information. Okay, well, first of all, you always put the total on the first equation. So it's going to be M, the number in the amount in Midland Bank, plus F equals 10,000. Okay, and now we'll deal with the interest in the second one. Okay, well, she gets 8% in the first one, so it's going to be, you'd put that as a decimal, so it'd be 0.08 M plus, so what you're saying is 8% of her total money in this bank plus 6% of her total money in the second bank equals the total amount of interest which she got, which was 640. Okay, so that's the tricky part, setting them up. Once you've done that, then you just, you roll to the calculator again. And so we'll go to, simultaneous equation solver, next. Once you've set it up, you're good to go. And then we'll just put it in. Well, in this case, it's going to be 1, 10,000. And then it's going to be 0.08, 0.06, and 640. Okay, and then we'll solve it. Oh, so first bank she had $2,000, and so in Midland Bank she had 2,000, and then in First National Bank she had 8,000. And make sure you put the dollar sign, or else you get a unit or a financial penalty. Okay, again, pretty simple, straightforward. You just have to, the setting up the equations here is the tricky part. But again, if you learn how, use your calculator as a tool that can help you. That app, this app here is amazing. We're going to be able to solve, in the next one we'll use it to solve quadratics, but in this case for solving simultaneous equations. It's really helpful. Okay, so anyway, that's it for now, and let's move on to the last subject in number and algebra. All right, for the fifth part here, we're going to do some quadratic equations, which can be a little tricky, but again, when you encounter a quadratic equation in the form of ax squared plus bx plus c equals 0, the best way to solve them is, again, use the polysimultaneous application on your calculator. You use number 1 polyroot finder in this case. Okay, so let's go ahead and do this. The diagram below represents a path x meters wide around a rectangular lawn, which measures 10 by 8 meters. Okay, no problem. Write down expression for the area of the path. Okay, well, this one's kind of tricky. Basically, what you're going to do is you're going to take the area of the whole thing and subtract the lawn. So the area of the whole thing, well, if this, is x here, and this is x here, and this is, obviously 10, well, that side here is going to be 10 plus 2x, or 2x plus 10. Now, it works the same way on this side. If it's going to be x here and x here, this side's going to be 2x plus 8. Okay? And then now what's the area of the lawn? The area of the lawn is 8 times 10, which is 80. So we're going to write down an expression in terms of x for the area. Well, so the area is going to be, 2x plus 8 times 2x plus 10 minus 80. Now I'm going to go ahead and work this out. You're going to have to FOIL here, or expand the brackets. So you're going to get 4x squared when you do that, and then plus 20x plus 20x plus 16x plus 80 minus 80. Okay, well, that's nice because that's going to go away. So the expression for the area is 4x squared plus 36x. Okay? Now, what is the width of the path if the area is 208? Well, now we just have to make this equal to 208. So we'll just do 4x squared plus 36x equals 208. Well, to solve quadratics, you have to move it over. So plus 36x minus 208 equals 0. Now, you can factor this, but I would just go straight to the app, quite frankly, because unless you're really good at factoring, it's going to be a waste of time. So go to polysimultaneous. We'll go to polyroot finder this time. I want to make sure my answers are in decimals. I don't want fractions for this one. Although my guess is they're probably whole numbers. Okay, so we just enter in the coefficients. So 4, 36, and then negative 208, and we solve it. And we get negative 13 and 4. Okay, so x is negative 13 and 4. Now, negative 13 makes absolutely no sense because it has to be positive. Okay, so what it's going to be is it's going to be 4. Okay, because it's the only thing that makes sense. It's positive. So the width is 4 meters. And you're good to go on that. Now, let's do one that's almost exactly like this, just so you get the hang of these things. I've seen a lot of these types of problems, so I'm going to do another one. Okay, so this one says a picture in the shape of a square of 5 centimeters is surrounded by a wooden frame with a width of x centimeters. Okay, so this is the exact same type of problem. The length of a wooden frame L and the area of the wood, the length of the wooden frame is L, and the area of the wooden frame is a centimeter squared. Okay, no problem. All right. So, well, that makes me wonder if I put. Yeah, I did put. I just want to make sure I put meters there. I was like freaking out for a second. Okay, so the length was okay. Write an expression for the length in terms of x. Well, okay, this is the same exact problem we just did. So this is x. That's x. So the length is going to be. Well, I should put the x's first. 2x plus 5. Or 5 plus 2x. Now, write an expression for the area in terms of x. Well, the area of the wood frame is going to be, basically 2x plus 5 times 2x plus 5 minus, this is going to be 5 times 5, so that's 25. So that's going to be minus 25. Now, again, I'm going to simplify this. So I'm going to get 4x squared plus 20x plus 25, and then it's going to be minus 25. So the area equals 4x squared plus 20x. Okay? Now, they say it equals 24, so, you know, let's just move it over here, and we'll go 4x squared plus 20x minus 24 equals 0. Okay, I made it equal to 24, and I just moved it over. Again, you can factor this out, but I'm not going to waste time doing this. I'm going to go straight into Polyroot Finder next, and, you know, it still has my old numbers in there, 4, 20, and negative 24. And then let's solve it. Okay, it's negative 6 and 1. Obviously, negative 6 is not going to work, so x equals 1. So it's going to be 1 centimeter. Okay, and make sure you put your units there. Okay, and you know what? We are good to go. You know, I mean, you could check this if you wanted to. Like, if this is, you know, if this is 2x plus 5, and this is 2x plus 5. Well, if you subbed in 1 for x, that'd be 7 times 7. So the area of the whole thing would be 49 minus 25. So that means the area of the frame is 24 centimeters squared. And is it 24 centimeters squared? It is. Boom. So we're done. Okay, so that brings us to the end of number and algebra. Some of these things are going to be repeated in videos coming up. I'm going to make 7 more. And, you know, hopefully this helped out. You know, make a comment. If you need me to help you out on anything, I'd be happy to. So anyway, I wish you good luck on your exams. Study hard.